miles. The projectiles simulate micrometeoroids and space junk. They slam into spacecraft parts at up to 19,000 miles an hour, creating disasters on Earth to better understand disasters in space. At such incredibly high speeds, a very small object can cause very big trouble.
I'm standing inside of our largest target chamber of our 1-inch gun. The gun is 175 feet long and can launch up to a 3/4 inch size projectile. I'm holding a target that was impacted with a 5/8 inch projectile, and as you can see, this is the entry hole, and it went all the way through the test article. An impact of this size would be a catastrophic event in space.
The only hope the International Space Station crew would have for survival is to put on emergency breathing masks and head to the re-entry capsule. An object less than an inch wide would have forced them to abandon this multi-billion-dollar facility. That type of scenario is the reason why crews are constantly adding extra layers of protection to the outside of the space station. For another type of space collision, we have only ourselves to blame. In 1997, a Russian cosmonaut had trouble guiding an unmanned cargo craft to its docking point with the Mir space station.
Now, we know in aviation that 70% of the accidents are human-related, so it wouldn't surprise you to think that humans have also a big role in accidents and mishaps in space. The Mir collision actually was because a crew member complained that he wasn't trained enough to do the rendezvous, and the ground control team said, well, you have to do it anyway. The hit occurred and it caused a leak in the cabin pressure, so now they started to lose cabin pressure. And then the space station started to tumble because it was like pool balls. One hits another, it causes it to move. So even a minor thing, just the control of a rendezvous and docking could have almost catastrophic consequence.
But the disasters that have happened in space still pale in comparison to the disasters of getting into space and returning. There is a saying that the first 50 miles and the last 50 miles are the most dangerous part of any mission. The 1986 Challenger launch disaster and the 2003 Columbia re-entry tragedy make that clear. But if we're ever going to travel beyond our solar system, we're going to need to move beyond our current rocket technology. One possibility that both thrills and terrifies is known as an antimatter engine. Inside massive particle accelerators, scientists have created minute amounts of antimatter, which is made of atoms that have the opposite charges of normal atoms. So with antimatter, the electrons are positive and the protons are negative. When matter and antimatter come into contact, they annihilate each other, releasing tremendous amounts of energy.
Antimatter engines have a 100% conversion rate of matter into energy. Realize that even an atomic bomb is only 1% efficient. Only 1% of the mass of an atomic bomb is converted to energy. In an antimatter engine, we're talking about nearly 100% of the mass converted into energy. It is, for the next century, the propulsion system of choice. But there's a problem.
A teaspoon of antimatter might be able to propel us across the solar system. But that same teaspoon also has the power to destroy an entire city. And once a spacecraft is out in deep space, simple accidents can suddenly tip the balance from life to death. As we venture to Mars and beyond, with journeys lasting years at a time, the chances of becoming stranded in space will become much greater.
For example, on a flight to Mars, what if a micrometeoroid punches an oxygen tank? What if you just are simply running out of breathable air? There is nothing you can do. You can die graciously is what you can do, however long it takes.
Another source of disasters, especially with journeys measured in years, is something that many people overlook.
One thing we forget is our fellow man, our fellow astronauts. If you're cooped up in this tiny little space capsule for, let's say, a year at a time going to Mars, or years going into deep space, you can go crazy. You can get claustrophobic. The guy next door could really get on your nerves, and you want to strangle him after a certain point.
Although the incidents aren't highly publicized, crew members have had problems getting along in the past with dangerous results.
There was at least one Soviet space station crew of the 1970s that didn't get along pretty famously and actually supposedly had a fist fight. These stresses are going to manifest themselves on these long-duration missions. Anybody who thinks they aren't is fooling himself.
And to make things even more interesting, Russian cosmonauts supposedly have firearms stowed on board as a precaution after an extremely off-course landing in 1965.
The crew landed up in the woods in Siberia and were there for about 3 days. And they had to fight off wolves until they were rescued. After that particular mission, the Soviets decided that they were going to put a sawed-off shotgun in every Soyuz capsule in case something like that happened again.
The cosmonauts are now rumored to have handguns stored in emergency kits. But no one is eager to offer any official details of guns in space. And the risk of having a weapon aboard isn't just a concern if tempers flare.
There is actually a documented case of a payload specialist who flew on a shuttle flight, whose experiment failed, and he spent his whole life getting this experiment ready. It failed, and he actually talked about killing himself. And the crew themselves actually tried to protect him and guarded the hatch so he wouldn't kill them.
Even with all of the space travel lessons learned so far, one thing is clear. Nothing can completely prevent disasters from striking in the future.
If we're going to continue human spaceflight, we have to accept the risk because it is a very dangerous occupation. But we have to manage the risk, and that's going to require good technical people and good leadership.
But just as surely as disasters will strike, there is another certainty when it comes to manned space exploration.
I think we have a gene for exploration, a gene for discovery. Not only is it good for our evolution, because we find new avenues to reproduce and to colonize, but I think it's also inside the spirit of human beings to want to know what's out there. Is it possible to reach areas that we've never been before? And the thrill of being the first person to explore new terrain, that's fantastic.